Good day, friends. Welcome to my channel, lecture series on power electronics. In this lecture, we will be discussing about a buck converter. Before going into the buck converter, let us understand the operation of a step-down chopper. Step-down chopper is a DC to DC converter. Let us see a simple circuit over here. There is a source, there is a load, and there is a switch. A DC is given as the input. When the switch is closed, there is going to be an output, and when the switch is open, there is not going to be any output. So if the switch is closed at a very fast rate, switching on and off is done using a high speed switch, then we will be getting pulses as the output, and the average value of the DC available will be lesser than the input DC voltage available. The step-down chopper can be seen as a DC equivalent of a transformer. So if the input is, say, for example 5 volts, and if the switch is closed for 50% of the time, open for 50% of the time, the output would be approximately half of what is the input voltage. So there is a term called as duty cycle. The duty cycle is the ratio of the on time of the switch divided by the on plus off the time of the switch. So after understanding this step down chopper, it is easy for us to understand what a practical buck converter is. The average output voltage of a step down chopper is given by VDC is equal to V into D. That is the duty cycle. The duty cycle is T on by T on plus T off. T on plus T off is the total time for a cycle. So by adjusting the value of the duty cycle, more precisely by changing the on timing of the switch, the output voltage available from a chopper can be changed. If the duty cycle is more, that is the on time is more, the output DC voltage will be higher, and if the duty cycle is less, the output voltage available will be less. Let us now understand what a practical buck converter is. A buck converter is also a step down DC to DC converter. Though theoretically we feel that a simple switch, a high speed switch is sufficient for conversion from a fixed value of DC to a variable value of DC, it is not just sufficient, because when the switching is done, there will be a sudden change in the current and the sudden change in the voltage. To oppose that, we need to include some other components also into the circuit. An inductor would oppose any sudden change in the current during the switching operation, and the capacitor will oppose any sudden change in the voltage. So a practical circuit consists of a high speed switch, which is usually a MOSFET, an inductor and a capacitor to control the energy transfer, and that too with the minimal power loss. Circuit diagram of a practical buck converter is shown in this image. Here the switch is replaced by a MOSFET, and it can be controlled, its switching can be controlled using a microcontroller. When the MOSFET is closed, the current will flow through the inductor and the load. The capacitor will be getting charged. Both the inductor and the capacitor components will store energy in their magnetic and electric fields respectively. Inductor and capacitors are used in this circuit, as the inductor will oppose any change in the current and the capacitor will oppose any change in the voltage during the high speed operation of the MOSFET, that is the opening and closing of the switch. When the MOSFET is opened, the energy stored in the magnetic field of the inductor will cause the current to flow through the load through the freewheeling diode. The path of current when the switch is on, when the switch is off, in a buck converter is shown in this image. During the on time of the switch, the current flow in the circuit is through the inductor and the load. When the switch is off, the energy stored in the inductor causes a current to flow through the load through the freewheeling diode. Buck converters find applications in laptop chargers, electric vehicles, and solar systems. So, in this lecture, we have seen about buck converters, which are DC to DC converters, step down DC converters, and they are using MOSFET for achieving this function. Thank you.